Okay. Right. All right. Hello, guys. How are you doing? Trust you're doing very good. And then I'd like to welcome all of you to this training. In today's training, we want to take a look at automation within the networking industry. Many times you will find that anytime we deploy networks, we tend to log into the nodes one by one, do the configuration, and of course, we are aware of the kind of workloads that comes in. So there are new concepts within the networking industry where we call DevOps, we call them automation, and one of the open source tools for automation is Ansible. And Ansible comes within the idea of an open source where it's saying it's very simple. What it's saying is that if at all times we always have to be configuring nodes one by one, managing nodes individually, which comes with the complexity of that. Also comes with the risks of today this person goes to deploy a configuration and may lose one or two things within there, which could misfire, and concepts like misconfigurations and all that could come in. So the idea is if we are able to do automation where we can prepare scripts and then we can issue AI to be configuring this kind of nodes ahead of time, we could offer some level of trust. We could offer some level of guarantee that whatever that we are sending over the API, that is what is called API. Basically, that's the interface for communication with the various nodes which we are going to use for the automation. We could ensure some level of security. We could ensure some level of scalability. For example, you do know that in the service provider core, we do configure more than 100. Sometimes you have as far as 120 and something amount of nodes that you're supposed to configure within the shortest possible time. You're supposed to deploy, configure BGP, all those kind of routing protocols that you do configure within your MPLS backbone, whatever you have. So the whole concept of today is about automation. And I will start by showing you this topology. So it's Ansible automation, and what we have is the traditional network where if I have five routers, router one connected, router two, router three, router four, router five, or whatever that you have, the idea is in the deployment phase of project management, we would have gone in to do our installation, ensure it passes our installation check. We would have had fiber connectivity between the various links also done. So once you have that, the next thing you're supposed to do is to go side by side. So supposing that the distance is very far, you have to go side by side. But it is not so now. Once we have an underlay, the underlay is we have some level of reachability. This is outside this network. Supposing that you are dealing with a one area network where a service provider is giving you the backbone connectivity, all you need to do is the service provider to provide you an interface for DHCP relay. Said that if you have a central controller system, we could use through DHCP lease out IPs to the various interfaces of our node, which we call the management IP interfaces. And through that, we can issue control commands to configure all these nodes ahead of time. And we are going to use Python scripts as well as Ansible comes with lots of playbooks. We will be looking at all those kind of stuff and how to do this kind of automation. So the general idea is our traditional way of configuring nodes. We want to automate it, and that is the goal of this project. I will start by making a couple of reference about if you want to have more ideas about the Ansible, you could check this link which I'm also going to post in my video and stuff. Then you can also check that and to give you full documentation of how to do network automation using Ansible. And in this place, we want to lay emphasis on using Fios, which is a Juniper router OS. And nevertheless, the idea of automation is for service providers as well as service provider to really ensure that there's an open source market and not necessarily tying a service provider to one vendor, but we could have an open source that uses a concept like an open flow, which was the general API interface that came for various automation. Okay, so I will start straight up by assuming that you already do know how to do connectivities, you know how to ensure there's routing reachability within your network using OSPF. And today, all we're going to do is to automate all this activity. Okay, good. So I have divided the project into two. So the first one is the build project phase, where we basically are going to build the router, ensure that we have this connectivity over our management system or our control system. The advantages of these generally include new technologies like the SDN. I do know that 5G, when we talk about segment routing, all this actually coming with controller. We actually gearing towards the road where we are more interested in source-based routing than destination-based routing. Because in source-based routing, the service that you want to send over the network has the ability to make requests, dynamic requests of the quality of service experience that requires over the route. And we do expect that the core layer should be able to provide this service and not necessarily dedicated services or dedicated capacity like what we used to do in RSVP, but they are dynamically allocated using concepts like network slicing, and then a couple of more where we have a central controller which sits over the entire network and gives you a full overlay of the network. Good. So let us proceed. So project is divided into two. We will be building the built network management system, and then we'll also be doing configuration. And at this point, I need to introduce two most important things about. Let me start by just showing the topology a little bit. So what we have is that we're building a controller, and this controller general in our lab environment we have the ghost, which is the Cisco API, a kind of ghost environment, okay? And then we will have Ansible playbook. Ansible playbook, very easy to download also from GitHub. And then we will also have Python. So this is going to form our controller. Generally within the industry, vendors have their own controllers or own software-defined networking solutions. For example, Cisco ICE and all that is over there. SDSS, they have a couple. SDS and the data center solutions also have DS as well as SD1 and all that. But in the lab environment, we are trying going to use this as the controller to automate the configuration of these nodes. So what we're going to do is very simple. We have a GitHub account where we keep our files, so we can be in our controller and then download files from this GitHub account. Generally, in the industry out there will be policies defined within this controller to host types of configuration you want to do, such as OSPF, whatever that you have. And then we will make API calls. So each of these Ansible has its own API interface that it basically uses. It's still based on the open source, open flow concepts. You also do understand that within the industry, they use APIs like the netconf, the RESTful, which is a northbound interface, all these to and which you must necessarily ensure that all these nodes do support the API accepting commands coming from API and not from a human readable interface. So our build file, we'll be using that to build a network topology, and we have another file which we are going to build for configuration. And the files are very easy to understand. And what I have put here is that the whole concept of automation, I have divided that into three. We call it the template phase, where you build templates to do specific functions. For example, we can use Excel to build templates to host the system names as well as the host name or the host names, and then basically the host IPs that you want to use for the deployment. We could also use YAML, which is the new tool, new automated tool which is being used. YAML and Ginger, they work concurrently to automate networks. So we can use Excel, we can use YAML to build these templates, and then Ginger provides us a mechanism to take these CSV files or the YAML files and then to output the scripts in a way that the nodes do understand. And we will use YAML, we will create another YAML template where YAML will going to introduce variables, the collections, and then the tags. So the tags is going to be how it's supposed to use the Ginger files as well as the templates that we have created to execute the various commands through the API so that it could be used to configure the nodes. So we could use a YAML template to build, let's say that, hey, go in and deploy OSPF on the entire network, go in and deploy BGP, go in and deploy ISIS, go in and deploy this kind of security configurations on the nodes. Okay, so that is what we're going to do. So the whole concept is we need to necessarily understand how to use YAML templating. We need to understand how to use Ginger files, and I have provided links for those really interested to have more ideas about this YAML files. We could go here to this YAML links and then the Ginger files, and then look at that. I'll provide them as well for everybody who is interested to look at that. I will develop specific videos on YAML templating alone, and then I'll also provide dedicated videos on Ginger files and how they are being used for automation within the networking industry for network engineers like us. Okay, so with this concept being clear, then all that I just have to do is we just rely on the various API calls. OpenFlow is an API source. Netcall is what is used mostly in the industry within the service provider network. RESTful is also an API which the nodes necessarily understand. I could give you an industry experience where if you are using very old software support routers, it is required that you necessarily need to upgrade your entire network to a certain software version where the nodes will necessarily support automation. Okay. Good. So with that in mind, we start with the build template. So in the build template, I'll be explaining what the nodes CSV is doing. Node CSV necessary is nothing else than just providing us the list of nodes, and I will provide some level of management IP addresses in there. Of course, links YAML, which is a template file which I'm creating in YAML and not necessarily CSV. It gives you that granite. You can always change it to anything that you want. Links, is very clear. I'm going to use that to input how the links are supposed to be built. Okay, and then the nodes will necessarily also giving me more information of how to build the networks over the topology. Do ensure that before you do any sort of automation, of course, you do agree with me that the nodes have necessarily been installed on sites. All the various PAT has been passed and customer is satisfied with the various installation. Okay, so these are the nodes that you're building, and then we have YAML files to actually execute, issue the various operations, and the various operations where it's going to make use of these templates as well as the Ginger files. Ginger files provide you a mechanism to do more looping, like writing a C program or whatever to output the script. I will give you full details of that. I just need you to have a general overview of what we are talking about first, and I'll show you the full content of all that we are doing here. So we'll be using the make file to actually go in to build the topologies for us once we have inputs from the nodes, the links, and then all that, as well as the Ginger template in making the Ginger template to make use of this. So in terms of this, you can see that name is clear. CSV to listen. What I'm doing is that once the underlay has been built, in other words, I want to issue DHCP to the various interfaces so that the controller can have IP reachability to each of these nodes in this 192.168.122 slash 24 network. So what I definitely do is in this part is going to the Ginger is going to take the content of the CSV files and then output a script that is understandable to configure the nodes to support DHCP. Necessarily, I also do have another one to take contents of the CSV files and others here to also build the network topology. All right. So these Ginger files necessarily they are standard for you go to Ginger. There are so many Ginger templates for whatever. Hey, if you want to build an OSPF, now if you want to build any kind of layer 2 you want to do spanning tree, whatever that you have templates for you to use. And in the industry also, if you go to the NMS for most of the controllers, there are so many templates. You only have to edit it to suit yourself. So the idea of where you have to be doing configuration from scratch is really fading away. The idea where you necessarily need to be vendor specific and you must be fully understand the syntax of Cisco is good, or you must necessarily understand the syntaxes of Juniper or Huawei or any other vendor out there is also fading away because we're looking at service providers who want to have open source today. I want to deploy a network where I'm using the same style of syntax using Ginger, using YAML, and both Cisco and Huawei and Juniper and Nokia and all these vendor specific nodes understand and can interpret the one single command or idea I want to present intent based. I can present and all these nodes will understand and reconfigure themselves in their own individual syntax way to output the intention that I want to give to the network. So I think I have been able to explain this concept very clearly to you. So of course, when it's done, we have a start YAML file to start the configurations as well for us. And then I also built this file with, for delete. And later I'll show you how I built it. Of course, you could have used just one YAML file show where that YAML file will take information from all the nodes that you want to build with their management IPs and stuff. Typical example, let me just give you a very just idea of what I'm trying to inform you about. So I just have this Excel template here in the build file. Okay, so this is actually content of what I'm talking about. So when I talk about, don't worry about these colors, they are just reference stuff. So when I basically want to talk about it is that if I, for example, if I want to do a make file, I have what are the variables that I should connect to. I will explain this is a very dedicated video, and then I have various tasks of what is supposed to do. For example, this necessary means that I should take the CSV list Ginger file and then use that to build the topology that I'm talking about. So the CSV list Ginger file I'm talking about, for example here, right? So that's this make file that I'm talking about over there. So it's just I will really be able to explain all this, but in a high level overview, I needed to understand how we do automation. So, for example, the no CSV that I talked about, which is a template, you will find that you only have to just input what are the nodes you have to put there, what are the installation coordinates I want to do, necessary, what are the management IPs I want to apply, and probably maybe the MAC address as well. And then you basically so is these are templates, these are the links templates that I talked about over here. Yeah, the links template I talked about, and then also the notes. I will go really into detail into each of these to make you clearly understand. Of course, it doesn't take a 1 day, but as I'm really going to explain as much as possible for you to understand all these concepts. So just keep your cool, my dear friends. Just keep your cool. We'll get there. Okay. So just build this template. And this template, the advantage of it is that these templates are all available over the internet. It's just a matter of you taking the template and editing. And in here, management can also view and then can be rest assured that what configuration you are going to do in the maintenance window will necessarily going to work because the templates are there and you are not logging into the notes where you're going to show fatigue and all those kind of things. Everything has been done ahead of time. So it's just a matter of using the Ansible playbook command to send commands to the node and then you'll be good to go. So let's get back to our topology and let me quickly finish up with a high level overview of what we are talking about. So good. So we took this templates that we've created, we took the gingers, mix it together and to output a set of commands which we are going to use for the operation. And the operation general for this will be variables collection and then taxes of what exactly is supposed to do, which we have done here. So the make is going to build a network topology. The start is going to start the machines up. And of course, you want to delete from the NMS layer. We could also write a script for that, which is the delete, which we have done. Necessarily, after this is just the builds, okay? And then have the configuration. So the configurations are necessarily the configuration you want to use for the nodes. One may say that these configurations are really too much, but it's not necessarily so because their configurations you see are repetitive, very repetitive. The advantage that it gives to you is that you have granularity to pick just one router and edit it according to what you want and then push it to the Ansible node and then the Ansible will use its API to push it downstream. And generally in the industry there, these automations have been made so easily that we have templates within the controller feature where you just take it to edit. It's in my lab environment here, I'm using the GNS3 environment. So literally you have to be creating all these templates, but it's not a big deal at all. Okay, so we do have the various files also here, similar to what I talked about, which we edit that as well. I have a file to input the username and password per various nodes. And of course, anytime you see the set, the save, the start, all those things are actually the Ansible playbooks for execution, which I have variables to tell me where to pick information from. I have collections of where I should take the libraries from, and I have tags of what's supposed to execute related to whether it's using Ginger files or YAML files to do the various communication. And necessarily, the key protocols I'm running here are NAT. I need NAT in a way because my Ansible my controller sits in a different environment. So I need nothing to cause it to be able to have reachability to the network. I have a layer 2 management switch, and of course, a layer 2 management switch, you definitely know that is using default VLAN 1. Of course, you know that in the industry, your VLAN 1 necessary needs to be disabled for security considerations as well. And I have DHCP to relay and issue DHCP commands to the various interfaces. And of course, what I'm deploying within the IP core or the core layer here is OSPF. I could also have had a syntax to do whatever thing that you basically want to do. So this gives you a very good overview of what exactly that you want to do. So all I just do is that we just changes and this template sits with you forever. Is generally something that you can easily edit and push it down to the notes at all times. Okay, all right, based on your individual needs. If there are any questions and that, you can always put it in my chat or in my page, and I'll be more than happy to respond to you and then to explain concepts more further to you. Good. So that is the high level overview of how we are going to execute all these files. I look forward to you joining me in my next video where we going to actually implement all these configurations. Let me just check how many minutes more that I have for this recording. I think we got a couple of more. Okay, just on 6 minutes more. So we can start a little bit by looking at the build files one by one, and then we can look at it before we do the various deployment. So I'll start with the build file, which is the nodes.csv. So the nodes.csv, we just go in here, and you can see the nodes.csv file is very simple. It takes what is the system name or the host name that you want to give to the nodes. You introduce a comma, you tell it the template, the name of the file that you just want to call it, whatever, and then XY just tells you that on your NMS GUI interface, what are the corner, where do you want the pictorial representation to be placed. I want to also introduce an IP address for it, which are there's a dedicated IP because you want to manage the box. You don't want the IP after DHCP relays the IP to the node and is configured. You want it to be static within the nodes. And this necessarily shows the MAC address payload. So you can clearly see that in my network topology, I'm deploying a cloud over here. Let me try break this up to two. Okay. So I'll try put this one right here, and then we can put this one here as well. Okay. I think that's fine. We can talk about that. So we deploy in a cloud. We have a cloud. We have a Vios 1, Vios 2, Vios 3, or Vios 5. We have four pieces we are deploying within the network, which we are going to issue DHCP to them. So consider them like Cs. And then we have a DMZ. For server connectivity or demilitarized zone, which has a web server and then Bash server over there. And then, of course, you need management to it. We have a management switch as well. And then we have NAT connection and management switch for the management. And one of the things that you need to understand by software-defined networking is that in a software-defined, we want to do simplicity. So we have necessarily separated the management plane from the control plane as well as the data plane as well. So management of our networks are totally separated so that management tends to be key more than even service in certain scenarios. So that is that. And then we have our next template, which is the links.yaml. Links.yaml just takes these files and then tell me that the cloud uses its interface BRT. That's how the program language looks like to connect to Vios 1 on E1. Very simple stuff. So you just list all your connectivities like this, and then we are going to send commands to really configure these nodes as they are. So that also takes that as well. Okay, for the links, and then also in terms of the nodes, let me see. I think I got a pause here, and then probably show you a couple of stuff, and then we can just pause right here. So here we are. So the files I talked about, the build files, so we can go cd dash build. So imagine this your controller. Most controllers are naturally GUI interface, and these are the files I was talking about. So necessary, I can do a nano nodes .csv to actually tell the content of the file. I can decide to edit these files the way I want it. If you want to delete any file, just delete like that. If you don't want to do, you can just do like that. You can do this, and then you Control S saves it, and then Control X kicks you out, and that is saved. So once we have all these files already done within our system, executing these files is nothing else than just typing Ansible playbook. Sorry, playbook, and then followed by the file name. So I think we'll continue this in our next video. I think so far we are necessarily just 2 minutes more. Okay, so we have Ansible playbook, then followed by what we want the file to do. So to make the file, we just copy that in here, and then we paste that and we hit enter. And the Ansible playbook necessarily takes all the information that is being required, picks out the tasks, executes all the tasks one by one, and then generally is going to output the configuration necessarily for us. Once I have a command to hit enter for it to continue, so you can see all the tags that I've issued within the Ansible playbook here of what it's supposed to be doing is actually what is executing. So that's the make file that is being executed. And here it tells me that it has fully executed the file. And if we quickly go to our GNS3 platform and then we try to find the file that was created, this is the file. I know it just now it just got created. And then we can start this thing up and just do that. And then here we are, our nodes all built for us one time. So whether you have 1,000 nodes, you have 10,000 nodes, and you have these Ansible playbook templates, and then you do understand Ginger, the use of Ginger as well as YAML templating, you are good to go. You can build your network topologies in fast times because we are looking in a world where